Hello students, but in previous class we completed up to 15th group elements, and now we are going to start 16th group element. That one is chalcogens, right? The group 16 sixth called as a chalcogens. But in this one only introduction part, instead of that I will say what are the elements included on that one. Here oxygen, sulfur, selenium, tellurium and polonium. If you know the atomic number of one element, we are able to write the atomic number of other elements and all. But one more point is that this group element belongs to 16th vertical column called as a 6th. And if you write their general electronic configuration, so this general electronic configuration of this element will come as a ns2. How many 6 are there? ns2 and p4. Means in s orbital we have 2 electrons, and in p orbital we are having how many? 4 electrons. 4 plus 2, 6 electrons are there in their valence shell. Is it clear? The first one. Now, as we know about this one, what are the elements present over here? So directly can we say beta by losing 4 electron, it may have its oxidation state, or it may have its valency that is a plus 4. By removing remaining 2 electron from here, it may also get the valency as a plus 6. Means it is the group which is having its variable oxidation state as a plus 4 and plus 6. Means it is having a variable oxidation state. So this is a general term on every group I used to write beta. But now we'll see about the occurrence. What is occurrence of this group element, how it will occur and all. So occurrence I want to discuss here. The first point. Sir, in occurrence, the first element is what? Oxygen. But as the first element is oxygen, we can say it is the most abundant element on the earth crust. Can we say? Oxygen is the most abundant element on the earth crust. Most abundant element on earth crust. Right, sir. So this is the most abundant element on the earth crust. About oxygen. That means, beta, it forms about 46.6% by mass. How much beta? 46.6% by mass on the earth crust, right? And the dry air, means the air does not have the moisture and all, it contains nearly 20.946% of oxygen by volume. That means your dry air, it contains nearly 20.96% by volume. It is a occurrence of the oxygen. Now, second one after the oxygen, what is the second element? We know, so sulfur. But how the sulfur will exist? Yeah. So beta, it is also the most abundant element on the earth crust. But here we can say sulfur will exist either in the combined form. Mostly it will exist only in the combined form as a sulfate. So sulfur will exist in the form of combined form, and that will be called as a what? Sulfate. Beta, what are the sulfates are there? Let me tell you some examples and common name of it. Calcium sulfate dot 2H2O. CaSO4 dot 2H2O. Beta, it is commonly called as a what? It is called as a gypsum. CaSO4 dot 2H2 called as a what? Gypsum. Beta, MgSO4 7H2O. Yeah. MgSO4 and 7H2O. Yes, sir. Beta, MgSO4 7H2O, commonly it will be called as a what? Epsom salt. It will be called as a what? Epsom salt. So one we are having a calcium sulfate with 2 water molecule called gypsum. MgSO4.7H2 called as an Epsom. At the same time, BaSO4, right, called as a barytes. BaSO4, and it will be called as a what? BaRyts, barytes. So these are, sulfur will exist in the form of its sulfate, right? Now, another one, beta, sulfur may exist in the form of its sulfide also. I don't have the place here, I'll write here, beta. Sulfur, it also exists in the form of its sulfide. Sir, what is the sulfide? We know, beta. ZNS, PBS, clear? Yeah, the called as a PBS. So PBS called as a what? Galena. Another one is ZNS, zinc sulfide called as a what? Zinc blend. Yeah, beta, ZNS called as a what? It will be called as a zinc blend. So sulfur may exist as a sulfide form, but a sulfur may exist as a sulfate form. These are the sulfate form of sulfur, and these are the sulfide form of a sulfur. Not only this one, means actually I wrote what? Sulfur in the form of a sulfide means PBS, ZNS, we can say. Again, copper pyrite is a CuFeS2. In metallurgy, it was given. CuFeS2 called as a what? Copper pyrites. CuFeS2 called as a what? Copper pyrite. Here sulfur is also exists in the form of its sulfide, right? But the traces of sulfur may occur as a H2S gas in the volcanoes. Right? Organic materials such as egg, protein, garlic, onion, mustard, hair, wool, they also contain the sulfur. Yes. About the oxygen, about the sulfur. Chalo, take a screenshot up to here. Right. Now, what we wrote here about sulfur exists in the form of a sulfate. Sulfur exists in the form of a sulfide. But the remaining elements are there. What is the remaining element? Selenium, tellurium, polonium. Polonium is a radioactive element, no doubt beta here. About this one, if we'll talk, this one is a radioactive element. So what about these two? Huh. But selenium and polonium, they are also found as a metal selenide as well as a metal telluride in sulfide ore. So I should mention here selenium and tellurium. Just I'll write on this side, beta. Selenium and tellurium will exist as a metal, but a selenium will exist as a metal selenide and tellurium will exist as a metal telluride. So it will exist as a metal selenide, it will exist as a metal telluride, and that to be where they are exist in the sulfide ores, right? So this is about the occurrence of selenium and tellurium. Now, I want to take out this one. We'll go for the properties, beta, general properties of 16 group elements and all. Mostly we'll see about the exceptional cases here because the remaining part which one you know, it is more than enough. For example, if I'll ask you, what is the general electronic configuration of this group element? It is a NS2 and P4, enough. What about atomic and ionic radii? Yes, sir. As we are coming down the group, atomic and ionic radii increases. Correct, beta? Because differentiating electron enters into the new shell. So point number one, electronic configuration of this group element. Sir, electronic configuration of this group element is NS2NP4. Then point number two, sir, what about the atomic and ionic radii of this group element? Sir, as we are coming down the group, atomic and ionic radii increases down the group. Sir, why it is increases down the group? Because differentiating electron enters into the new shell. As a differentiating electron enters into the new shell, we can say atomic and ionic radii also increases. Is it clear, beta? Yes. Now, ionization enthalpy. Sir, can we say ionization enthalpy? Yes, sir. As the atomic radii is inversely proportional to, we know na beta. See, atomic size is inversely proportional to ionization potential. Means as we are coming down the group, atomic size increases. That means ionization energy decreases. Ha beta, I'll write here. Ionization energy, it will be decreases. It will be decreases down the group. So in the first case, ionization enthalpy, sorry, atomic and ionic radii increases, but ionization enthalpy decreases down the group. Right, beta? Why it is decreases? We know that as the atomic size increases, attraction between nucleus to valence electron decreases, and hence we can say ionization enthalpy decreases. Next one, we'll go with a electron gain enthalpy. Yeah, very important and exceptional cases are going to see, we are going to see in this part, beta, where especially for the electron gain enthalpy. Electron gain enthalpy. This is an exceptional case we have to learn. But we know that generally atomic size and enthalpy also inversely proportional. But in this case, it is not like that. We know that sulfur key value, what is the matter? The ionization enthalpy, sorry, we can talk about the electron gain enthalpy. But the electron gain enthalpy of sulfur will be greater than that of oxygen. But in this case, if you want to see here, sulfur, selenium, tellurium, polonium as a radioactive, and after that we are coming for the oxygen. This is a point we are going to see. It is a electron gain enthalpy, or you can say it is the order of electron affinity. That means oxygen, as it is a gas, it is having a lowest electron enthalpy, lowest electron affinity for the oxygen, and sulfur will have a highest electron gain enthalpy or electron affinity. Right, beta? The less negative electron gain enthalpy than that of sulfur. That means sulfur will have more, right? Sulfur, the value become a less negative up to polonium. You can see the chart over it. It doesn't matter. Next one is exceptional case, beta. Next one will come for the electronegativity. Beta, fluorine is the most electronegative, and here electron negativity, what we can say, so it will be decreases down the group. That means our oxygen is the second most electronegative element. It is the second most electronegative element, and value of oxygen is beta 3.5. That is electronegativity value for the oxygen. Do you remember? Right? Chalo. That means what we can say, beta, based on electronegativity, what we can discuss, sir? We can discuss that the metallic character increases down the group. How about electronegativity say what we can decide? Yeah, we can decide the metallic character get increases down the group. That means from oxygen to polonium. Hence we can say the metallic character, it will be increases down the group. Right, beta. But in this one, see here, electronegativity value get decreases down the group. That means oxygen is the second most electronegative element after fluorine. After fluorine, you know, fluorine ki value is electronegativity value is 4. So that is second most electronegative element after fluorine. So fluorine is 4. So oxygen value is 3.5. That means metallic character increases down the group. It is about this one. So if you want to write some more properties of it, let me tell you what is some more properties. For example, physical properties of this group element. But what is the physical property? You know, oxygen, and suppose if you want to discuss here oxygen. Sir, oxygen, it is a gas, but a sulfur, it will exist in the form of a solid. So oxygen, sulfur, selenium, tellurium, polonium, they all exist in the form of a solid, except that oxygen is in the form of a gas. But it is a first physical property, or we can say physical appearance. Not only that, some more property also we can say. But oxygen, sulfur, selenium, tellurium, and polonium. If we'll talk about all these things here, oxygen, sulfur are the non-metals. Remember, sulfur, selenium, tellurium, you can see metal lead, and polonium, when it was, if you see, it become a radioactive element, but it will be considered as a metal or radioactive element. So I should say here, selenium, tellurium are the metallite, polonium is a metal, but oxygen and sulfur are what? They are the non-metal. That only we said beta here. As we are coming down the group, metallic character increases. So oxygen, sulfur, non-metal, selenium, tellurium are the metalloid, and polonium, it is a metal, but it is a radioactive. But as it is a radioactive, obviously it must have some, it's a half-life period. And according to NCRT beta, the half-life period for polonium is given as a 13.8 days. It is given in the NCRT value, that is equal to what? 13.8 days are the half-life period for what? Polonium. So take a note of this one also. It is a general properties. Correct? So it is a physical nature, it is gas remaining solid, metallic character increases, right? But atomicity is also one of the concept they will ask here. What is that, sir? Atomicity. But atomicity mein, oxygen is a diatomic molecule. That means the number of atom present in a molecule called its atomicity. But a sulfur, it is a tetraatomic. It is a, sorry, octaatomic. It is a octaatomic molecule, because acid together will make a one molecule of this one. So they all are exist as a polyatomic beta, right? So S8, S5 and all, they will come under the polyatomic, but oxygen is a what? Diatomic gas, right? So we'll see the chemical properties with the first one, oxidation state and trends in its chemical reactivity. That is the important point we are going to see here. Chalo. These all are general property we can say beta, or physical properties we can say for the 16 group element. But now completely chemical properties we are going to start, where we are going to see about the oxidation state and its trends in the chemical properties or trends in the chemical reactions. So the first one is oxidation state. But our concept is same. General variable oxidation state of this group element is what? +4 and +6. So stability of +4 increases down the group and stability of +6 decreases down the group. Same concept is here. So now we'll start about chemical properties of this group element. But while writing the chemical properties of this group element, the first one which one we are going to discuss, that is about oxidation state. Sir, in oxidation state, what we saw, beta, the general electronic configuration of this group element is what? Sir, Ns2 Np4. By losing 4 electron +4, by losing remaining 2 electron +6, means it is having a variable oxidation state. It is having a variable oxidation state. +4 and +6 are the variable oxidation state exhibited by whom? The 16th group element, right? In this one, the point was clear here. +4 and +6 means simply we can say, sir, stability of lower oxidation state like a +4 and stability of higher oxidation state, that is a +6. But a stability of lower oxidation state, what is that? Increases. Shall I write in the bracket? Yeah, down the group. But why it is increases down the group? Till now you wrote the reason. The same reason now also you should put here. Yes, sir. Due to inert. What is that? Inert pair effect. Not the inert gas effect, beta. It is a inert pair effect. So due to this inert pair effect of this stability of lower oxidation state increases. And stability of +6 higher oxidation state, it will be decreases down the group. Yes, sir. It will be decreases down the group. Right? So this is the general form what we wrote here. At the same time, this element also have the tendency to exhibit the -2 oxidation state. 4 + 2, 6. That means by gaining 2 electron, it may also have -2 oxidation state. So what is the stability of -2 beta? That also decreases down the group. So again, we can say stability of -2 oxidation state also decreases down the group. +4 increases, +6 decreases, -2 decreases down the group, right? Very good, beta. Write down this one.